ahead and find another LCD. So I want to find the LCD for the following denominators. I've got 10AB and 5A. Well, 10AB is made up of a 10 and an AB. Remember, AB just stands for real numbers. Got A and B. 10 is 2 and 5. I've got 5A. Well, that just factors into a 5 and an A. So if we use this vertical column method, first I'm going to take a look at 5A. I've got a factor of a 5 and a factor of A. When it comes to 10AB, I have a factor of 2, which is new, a factor of 5, which matches, a factor of A, which matches, but a factor of B, which is new. So my LCD is going to be 5A times 2 times B, which is going to be 10AB. So that's going to be my LCD. So let's go ahead and find the LCD, and remember not to forget to simplify your functions. So for problem 1, I've got 5/9 plus 1/10. 9 factors into a 3 and a 3. 10 factors into a 2 and a 5. If we were going to do the column method, I don't know why I was trying to rush through that, I'm sorry. If we were going to try and do the column method, 9 would factor into a 3 and a 3. 10 would factor into a 2 and a 5, so the LCD would be 3 times 3 times 2 times 5, which is 9 times 10, which is 90. So, how do I make 5/9 look like 90? Well, what I'm going to do is I'm going to find an equivalent fraction. I'm going to multiply the numerator and the denominator by 10, because if I'm multiplying by 10 over 10, 10 divided by 10 is 1, right? Any number over itself is 1, and any number multiplied by 1 is just itself. And this equation on the right, I'm going to have to multiply by 9 over 9 to get the denominator of 90. So I've got 50 over 90 plus 90, not 90, plus 9. So we multiply our numerators and we multiply our denominators, plus 9 over 90. Oops, I guess we're changing color, which is 59/90ths, and I can't simplify that any further. Let's take a look at 6/7 minus 3/5. Well, 7 and 5 are both prime. They can't be broken down into any other factors. So my LCD is going to be 5 times 7, which is 35. So on the left here, I'm going to multiply by 5 over 5, again harnessing the power of 1. They don't tell you this often, but 1, while being the loneliest number, is also the most powerful number. So I've got to multiply by 5 by 5 on the left and 7 by 7 on the right, again working to find equivalent fractions. 5 times 6 is 30, 5 times 7 is 35, minus 3 times 7, which is 21, over 5 times 7, which is 35. 30 minus 21 is 9/35. And I can't simplify this anymore, but I should always check. I've got 4/7 plus 2/3. Well, 7 and 3 again are both primes. The LCD of 2 primes is going to be their product. So I multiply by 7 over 7 and 3 over 3. And note this only works because both denominators are prime. And the LCD of 2 prime numbers is going to be their product. So that gives me 12/21 plus 14/21, which gives me 26/21, which I can't simplify any further. The second problem is going to take a little bit more time, so let's make sure we definitely set up our factor trees and use the table method. So if I have 1/18 minus 3/8, 18 is going to factor into a 2 and a 9, which forms a 3 and a 3. And 8 factors into a 2 and a 4 and a 2 and a 2. So to find the LCD, I want to collect all the factors they have in common. 18 factors into a 2, a 3, and a 3. 8 factors into a 2, and then 2 more 2's that aren't accounted for. So the LCD is going to be 2 times 3 times 3 times 2 times 2, which is 72. That is correct, 72. So in order to make 18, here's kind of a cool trick. What do I need to multiply by 18 by to get it to look like 72? Well, it's going to be the 2 factors that denote in common, which is going to be 2 times 2, which is 4. Okay, what do I multiply 8 by to make it look like 18? Well, it's going to be the 2 factors that they didn't share, which is going to be 9. So that gives me 4 72nds minus, sorry, I don't know where I wrote plus, minus 3 times 4 is 12. Nope, that's a 9. Can't even read my own handwriting. 3 times 9 is 27. 70 seconds. 4 minus 27 is a negative 23, which thank goodness is a prime number, so I can't simplify this any further. Lastly, let's talk about improper and mixed fractions. So an improper fraction would probably be good to define. An improper fraction is one where the numerator, so the top of the fraction, is greater than the denominator. Okay, why is this improper? Well, let's take a look at an example. Let's say I had 4/3. And let's draw this as a picture. So I've got 2 circles broken up into thirds, and I've got 1, 2, 3, 4/3. You can see here I have 1 whole circle and 1/3 of a circle. So 4/3 is really 1 and a third, right? Typically in math, when we're solving problems, you can always leave fractions improper. That is cool. Improper fractions are good and proper and right with me. But you do need to know how to convert between an improper and a mixed fraction. If I wrote 4/3, which is equivalent to 1 and 1/3, this right here on the right is a mixed fraction. It's mixed because it's got a whole part and a fraction part. So mixed has a whole part and a fraction part. So how do I write an improper fraction as a mixed number? First, you divide the denominator into the numerator, and you identify the quotient, remainder, and divisor. So let's look at this first example. If I divide 9 by 5, I see that it fits in 1. That's our quotient, i.e. what we get when we divide it. Our remainder is going to be 4, and our divisor is 5. So we write the mixed number as quotient plus, not equals, quotient plus remainder over the divisor. So this would be 1 plus 4/5. So 1 and 4/5. Let's work through another example. If I have 7/3, I could take 7 divided by 3. 3 goes into 7 twice. 2 times 3 is 6. My remainder is 1. So here's my remainder. Here's our quotient. And here's our divisor. So I would rewrite this as 2 and 1/3. You never need to convert to a mixed number unless you are told to. When you're given a mixed number though, I do highly suggest you change it into an improper fraction. It makes life really easier to go ahead and add and subtract and multiply and divide fractions. So here's how we switch from a mixed number to an improper fraction. Step 1, you multiply the whole number by the denominator, and you add the numerator to the product found in step 1. So if I have 1 and 3/7, that's like saying I have 7/7, because 1 is 7/7, and 3/7. So in this method, if I took 1 times my denominator, and I add that to the numerator, and I put the final sum over my original denominator, I get 10/7. If I have 2 over 1/4, 2 and 1/4, that'd be 2 times 4, so my whole part times my denominator, plus my numerator over my original denominator, and I would get 9/4. So this was really a brief introduction, refresher into fractions. And if you have any questions, feel free to reach out to me, comment on this video. I would be happy to help and give you more examples.